We're all recording.
Alright.
Okay, so the my plan for this week was that today we would just meet and I would go over checkpoint problems with you guys and then probably give you some practice problems for the quiz. And then I'm going to post the quiz tomorrow and you'll have until Thursday to finish it. And then Wednesday and Thursday I'm going to post the next 2 sections of notes. But we're not going to quiz on that until after spring break. So it's kind of one of those things where I'm posting those videos and I'm going to ask you guys to try the checkpoint problems from those videos, but we're not going to do anything about the quiz or any review for that quiz for that section until after the break. So just kind of giving you a heads up. That's just kind of the way things fell for this class. And then Friday is Good Friday, so we're not going to have school. I'm not going to post anything. Other classes shouldn't be posting anything. And we'll be resuming next Wednesday on April 15th. So that's the plan. I also put in the note that if you're missing any assignments and you need to make up any of them, you'll need to do so by this Thursday. I've been trying to catch up on grading on Power School. From what I can tell, for the most part, you guys are all pretty much caught up to the period from before we went on break. So if you're missing any assignments from the last week, that's more or less all I'm talking about. So I'm slowly but surely getting everything updated into Power School. So that is what I got. So, all right. So, first things first. Did anybody have any questions about anything I went over in the videos?
Yo, my internet just like broke.
Oh, yeah.
It was crazy.
That's crazy, bro. But I don't remember asking.
Oh, that's why I was gone.
Gotcha. My Wi-Fi has been having issues. Anything directly connected to the router is not having issues, but my phone and my laptop can't. Like every time they try to join the Wi-Fi of my house, it says that there's no internet. So I'm like, what's going on? But not every device is having that problem. Like I have smart devices that are still doing just fine on the internet or the Wi-Fi, and my Xbox is doing just fine on the Wi-Fi for some reason. But I don't know why my phone and my laptop are doing that. So I can sympathize.
You have Minecraft Java Edition?
I have Minecraft Java Edition? Is that what you're asking me?
Yeah, do you?
I would have to pull up Steam and see if I have anything.
It's not on Steam, so you
It's
probably
not on
don't.
Steam, so then I don't have it on Steam.
You should buy it. It's only like $30. You can join our server. We already beat the Ender Dragon, but
if I have the Xbox Game Pass,
you guys beat the Ender Dragon without me.
Did.
I hate all of you. Nope. I'm not getting on the server ever again. Never getting on the server ever again. Screw you guys.
IP is Mikey
Nope.
is ugly.
Screw you. Screw you. I'm not getting back on it now.
Or Mikey. Oh, man.
He came out of hiding to say, "You beat the Ender Dragon without me."
Like I don't even have more than iron armor, and you guys are gonna
Oh,
beat the Ender Dragon without me.
We also, me and Mark got Elytras.
Yeah, all right. No, I'm not playing with you guys anymore.
Eric's probably listening and watching this and going, "I'm not Mike. Mikey's not the only one they beat it without." Oh my goodness.
We did not invite Eric.
Eric's like, I was there too.
Oh man.
Yeah. We mainly did it to spite Ivan, to be honest with you, Mikey. Because we had to teleport because we weren't gonna walk all the way back. So we just
I hate you both.
We did.
I'm not getting back on the server. I want you to understand that.
What?
You can make a new one.
We have been grinding. We didn't even beat the Wither.
Yeah.
The Wither has no like correspondence to the game.
Yeah.
The
If it
Nether
makes you
Star.
feel any better, Mikey, I got the final blow. I haven't done anything this entire time, and I got the final blow on the Ender Dragon.
Hmm.
Mr. Walter does not
Yeah.
care.
I'm
Who's
just chilling over here.
Huh.
This is
So
all on the recording.
I'm gonna be setting up to present because I have a set of slides made up with the checkpoint problems, so I
Not if
can
I
go
get
over them for you guys if you guys are okay with that. Since that's
Whenever
kinda
Miss
why we're
Cranky
gathered.
leaves her chat, I used to just present Tetris, and everybody would watch. And by everybody, I mean John.
Yeah.
Well, my PC I have set up with 2 monitors, so I have to figure out if the present now if I need my stuff on the one monitor or the other. I'm not sure. So
It's probably whichever one you have the tab open on for the
it
meet.
says I can present my entire screen or a window. I want my entire screen because I'm probably going to be pulling up the calculator. So let's see. Oh, I can choose which screen. Sweet. All right. Can you guys see this? Let's see.
I can.
Yes.
You can see my smart notebook file with evaluate the 6 trig functions at each real number.
Yes.
Mhm.
Awesome. Cool. All right. So as I had explained in the videos, with these types of problems, you're going to be looking to find the, let's see, I'm going to have to write it out, and it's going to be excruciatingly long. Sine of your angle. You got the cranes going yet, Alex?
Not yet. I'm making them.
Not yet. Okay. The sine of your angle. This pi over 2. You know what I wish I had put in this set of slides is that unit circle, or at least the remnants of one. Let's see. Let's see if I can pull up a unit circle real quick. So, this might help. Ordinarily, when I teach this section in class, I'll actually print out. There's a whole. I'll usually print out this PDF right here. And I usually hand it out and have you guys fill it out. And it's one of those things where I would let you guys use it on quizzes and tests and homework assignments and what have you throughout the entire 2 or 3 chapters of trigonometry. This is one of those go-to handout things. And what it is it's a kind of a handy place to be able to write all of the convenient angles that were on that one page in your textbook, page 271. And you can write out the angles in degrees, you can write out the angles in radians, and then you can write in all of the coordinates for each of those types of angles. And they have a space for each of them. So this would be 0 degrees here, 30 degrees here, 45 degrees here, 60 degrees here, 90. You get the idea. It kind of goes around. These middle lines are all multiples of the 45-degree angles. So 45, 90, 135, 180, yada, yada, yada. And then these lines that kind of are the outside, they're all multiples of 30. 30, 60, there it is. 120, 150, 180. And then all the pi angles as well can go in there. You can do 0, pi, pi over 2, pi over 4, pi over 6, pi over 3. You can write it all out and have it in one place. So if you want, you can print this out and in your house or copy it down on a piece of paper and write it all out so you have it handy with you, because I find that that's really nice to have when we're doing problems like this one. Because we're going to be referring to this and we're going to say, all right, in your textbooks to man, I really wish I had copied this in here. Let me pull up my notes from the video that I did with you guys. Which one's the completed one? Because having those definitions of trig functions on page 271 is really handy for doing problems like this. And I got to get going because we got, what, 35 minutes left?
On board, bro. Take
Or
your
less,
time.
actually. It's till 11 is my original plan. Come on, Smart Notebook, boot up. Here it is. Okay. I'm going to take this thing and I'm going to slap it in the other set of slides so we can refer back to it. All right. So the sign, we're going to need to go through all 6 of these. So in the video, I mentioned that the sine of your angle is equal to the y coordinate. The cosine of your angle is equal to the x coordinate. Tangent of your angle is equal to the y coordinate divided by the x coordinate. You can get the idea. I'm not going to keep going. So the sine of pi over 2 is just going to be the y coordinate, pi over 2. All right. Got to erase. Did you guys like this giant swirly angle?
Swirly angle.
Giant swirly angle. All right. Pi over 2. Since 180 degrees is pi, half of that, pi over 2, is going to be 90 degrees. So we're focusing on this coordinate point, 0, 1. Just so we have it up here, 0, 1. So the sine of your pi over 2 is just the y coordinate. So sine of pi over 2 is just 1. Cosine of pi over 2 is going to be the x coordinate, which is 0. This is a terrible tangent. Do you guys know what the tangent of pi over 2 is going to be?
-1. I'm just guessing.
Half.
Well, tangent is the y coordinate divided by the x coordinate. So the y coordinate divided by the x coordinate, what's going to happen?
Undefined.
Undefined. Thanks. Yep. Our tangent's undefined here. It's not the only one that's going to be undefined. I'm just going to write these out real quick. In the videos, I edit out this part. So all of these are just reciprocals of these. Technically, the sine is the sine over the the y value over the radius. So when you reciprocate this, cosecant is just going to be 1. This one, when you reciprocate this, what happens over here? Do you know?
Is it undefined?
It's undefined again because you get the 0 in the denominator. That's correct, Mar. And then this one, it was 1 over 0, and now it's going to flip. So it's going to be 0 over 1, which is just 0 for the cotangent. Okay. Does anybody have any questions about that? Like any particular part of it? I'm not sure. Just want to make sure. Okay. Part B for 0, your angle 0. If your angle is 0, you're using this coordinate, 1, 0. So for part B, it probably felt, if you did it on your own, it probably felt very similar to part A, where you're going to have these 1s, 0s, and undefineds that pop up. So for part B, checkpoint for part B. Oh, I'm looking at the wrong example in my textbook. Part B, the sine of 0 I might not write all this out. Well, maybe I can type it out. Anybody know what the sine of 0 is? Anybody
No.
do the checkpoints? You don't know, Alex?
Is it
Take a look.
zero?
So yes, the sine of 0, if your angle is equal to 0, look for the y coordinate for sine.
Oh.
So it's just 0.
Well, I'm not gonna answer because I think everybody else deserves a chance to answer.
Yeah. What did I say? It was 1
haven't
comma
picked
0
one.
on the coordinate point. Terrible, but I'm just going to deal with it. Cosine of 0 is the x coordinate. Just 1. What do you get for the tangent? Y over x. So if it's y over x, you do 0 divided by 1 equal to 0. Okay. Cosecant of 0. That's going to be the y value, or no, 1 divided by the y value. Define. Secant. That's 1 divided by your x value. Is cotangent is your x value divided by your y value. Just a heads up, ladies and gentlemen, if you're trying to find the 6 trigonometric functions, if you figure out that one of them's undefined, there's going to be another one that's undefined. They usually come in pairs. So in this case, cosecant and cotangent were the undefined ones. In the last problem, it was tangent and secant. It also just so happens that you can't get undefined solutions for sine or cosine because it's always just your x or your y value. Any questions on that?
No, sir.
Thanks, Marv.
I don't know.
All right. I don't see any comments on the chat either. So sounds good. All right, part C. I'm just going to type them out. If you have questions, you can answer it or ask me. Instead of typing out negative 5 pi over 6, because I really can't type that out in Smart Notebook, I'm just putting sine of t and cosine of t. You guys know what the angle is. It's up there. All right, here's where things get tricky. I already have this. All right. Those are the solutions. This is the one I kind of expect a little bit more of a how did I get that kind of a situation. So negative 5 pi over 6. If we refer back to the unit circles that we've got over here, negative 5 pi over 6, that's a multiple of pi over 6, and it's negative, so it's going clockwise around the circle. So this is 1 pi over 6, 2, 3, 4, 5 pi over 6. So this is the coordinate point we're using for this problem. Negative square root of 3 over 2, comma, negative 1 half. So the sine and the cosine are the easiest because it's just the y and the x. Y and the x. Boom, boom. Tangent is this divided by this. So you get a fun big old division problem where you're doing a fraction divided by a fraction. When you divide a fraction by a fraction, you keep, change, flip. Keep the first fraction, change this to multiplication, and then flip it to this. When you multiply this out, you're going to have negative 2 divided by 2 over this, so the 2's are going to cancel out. This is going to simplify to negative 1 over negative square root of 3. The negatives are going to cancel out, but then you have to rationalize the denominator. One times the square root of 3 is just the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is just 3. So that's how they got the square root of 3 over 3. Then everything else is reciprocals. Cosecant is the reciprocal of sine, so you just flip this fraction. Becomes 2 over negative 1, which is negative 2. Secant, you're going to flip this one. You're going to get 2 over negative square root of 3, and it's just like this problem. You're going to have to rationalize the denominator. And this is going to end up becoming the square root of 9, which is just 3, and the 2 times the square root of 3 sticks around in the numerator, and because it was negative, it's negative. And then the cotangent's the reciprocal of the tangent. The easiest way to think about this one is to go back to this step. You'll be at 1 over the square root of 3. If we reciprocate that, you just get the square root of 3. Because if we went backwards and we reciprocated this to make it 3 over the square root of 3, you'd have to do the rationalizing again, and you'd just end up right there with the square root of 3. So the multiples of pi over 6, I feel like, are probably the ones that trip people up the most, just because there's this square root of 3 going on here. All right, part D. I'm going to type this one out. Negative 3 pi over 4. If it's negative, you're going clockwise. We're not going to use that circle because that's multiples of pi over 6. Here's a multiple of pi over 4. Negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. Here's our angle. Negative square root of 2 over 2, comma, negative square root of 2 over 2. All right, I'm going to type this out. It's the same kind of problems. The sine of the angle is just your y value, the cosine's your x value, et cetera, et cetera. Whoa. Why did it get... That's funky. So the tangent is this divided by this, and since they're identical, anything divided by itself is just 1. I'm going to make a new text box over here. Right. Cosecant's the reciprocal of this fraction, so 2 over the square root of 2. Well, technically the negative square root of 2. And when you rationalize this one, some of you might be able to see what's coming already. You're going to get a negative answer. The square root of 4 is going to become 2, and the 2's are going to cancel out. So that's your answer for cosecant. Because secant is the reciprocal of this, and we already found the reciprocal of that when we did this. That's easy. And then cotangent. Anybody know what cotangent's going to be? Alex is shaking his head and sliding back in his chair. Well, cotangent's just the x value over the y value. When you have identical things in the numerator and denominator, 5 divided by 5 equals
1.
1. So the negative square root of 2 over 2 divided by negative square root of 2 over 2, it's the same idea as 5 divided by 5. It's just going to be 1 when you divide them. That took all of my time. Goodness. All right. Let's see if I can do these other ones faster. Use the period of the cosine function to evaluate cosine of 9 pi over 2. So for part A, ladies and gentlemen, they're giving you an angle that is technically larger than 2 pi. It's larger than 1 full rotation. So to find the angle that it would, or to figure out how to evaluate this, we've got to find the coterminal angle, which means you're going to take the 9 pi over 2 and you're going to subtract 1 full rotation from it and see where you're at. If you're within the 0 to 2 pi range, you can just evaluate it like we had done in these problems and just looked at where the angle was on the unit circle and looked for the x coordinate. 2 pi, we need common denominators here. This is going to be 4 pi over 2. So now they both have common denominators. You subtract, you're going to end up with 5 pi over 2, which is still larger than 2 pi. So we're going to subtract another 4 pi over 2 because 4 pi over 2 equals 2 pi. And that gets us 1 single pi over 2, which is in the unit circle. Pi over 2 is just this angle, 90-degree angle, 0, 1. And when you evaluate the cosine is the x-coordinate. So this is not the right slide. There we go. The cosine of this is going to equal 0. That is all A is. B, same kind of problem, except they give it to you in negative version. We've got to change this. Nope, not 2. Eraser. We've got to add, to get 2 pi into something over 3, that's multiply the top and bottom by 3 so 6 pi over 3, that's equal to 2 pi, just so you know. Negative 7 pi over 3 plus 6 pi over 3 gives you negative 1 pi over 3. That's really close to what we want, but it's technically not within the 0 to 2 pi. So we still have to add another 6 pi over 3 to get it to become positive 5 pi over 3, which is in our unit circle. I gotta go back to this one. Positive 5 pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. There's your coordinate. 1/2 common negative square root of 3 over 2. And so, are you giving them the entertainment they deserve over there, Alex?
Obviously.
Give them something to watch while they're listening to me. All right. The sign is the y coordinate of that, so the answer to this one is that. Negative square root of 3 over 2. Are they in like a death battle? What's going on over there?
Don't worry about it. This is the.
It would be entertaining if they were in a death battle.
This is their kid.
Oh, that's
we
the
don't
kid.
really care about them.
Okay.
Yeah, it's a long, complicated story. You wouldn't get it.
Oh, okay. That's fine. You can write the backstory out and post it somewhere.
Yeah.
All right.
Okay.
2C. I'm on the second to last checkpoint problem. Cosine of. They want to know what the cosine of your angle is if the negative version of that angle gives you an output of positive 0.3. So if the negative angle gives you an output that's positive, when you're taking the cosine, you're trying to find the x value. So if the output of your angle is positive, that means that your angle, your negative angle, is probably down here in the fourth quadrant. So the positive version of that angle would be up here in the first quadrant. And since the x value, let's say if your angle was negative pi over 3, you would have this angle right here. Your x value would be 1/2. Positive pi over 3 is up here. It's an identical identical x value. So in this case, if your negative angle gives you a positive x value of 0.3, your positive angle is going to give you that same output. Does anybody have questions about that? I can understand if that's a little bit confusing. The idea is because your output of your negative angle is positive, the positive x values are only found in the first and fourth quadrants. Anything to the right of this y-axis, first quadrant, fourth quadrant. So if your negative angle is down here, giving you an x value, the positive version of that angle is going to be in the first quadrant, and it's going to have an identical x value for its coordinate. Okay. Do you guys have any problems with evaluating these using the calculator?
No, the calculator one's pretty good. I could get that.
Yeah, that's not too bad. When you pull up your calculator, just make sure that the mode is in radians when you're evaluating these. Oh, wrong. So if it's 5 pi over 7, when you're taking the sine, you're just typing in sine 5 pi divided by 7, enter, and there's your answer. And then the cosecant of 2, you just got to take the sine of 2 and then do 1 divided by that answer. And that'll give you the cosecant. So this is the solution for part A of checkpoint 3, and this is the solution for part B. Okay? Any questions on anything that I just went over for this section of notes for the checkpoint problems?
I
don't think
think I get it.
Okay. So I'm going to be posting the quiz tomorrow. And the main idea with the quiz is that you're able to just evaluate the 6 trig functions. And if you have an angle that's larger than 2 pi or smaller than 0, you're just going to have to find the coterminal angle that's within 0 to 2 pi, and then you can evaluate it. I'm not going to give you any funky angles like if I do give you a funky angle, it'll probably be something you use the calculator for. But
Okay.
even if you're not sure that you did it right, like in a problem like this one, if you're trying to find the sine of this angle, you can type out the sine of this angle in your calculator. The sine of -3 pi over 4 and enter it. And then you can also type in the answer that you might have gotten, like this one, -square root of 2 over 2 in the calculator. -square root of 2. Oh, I don't want that. Divided by 2. Enter. And if the answers match, then you know you did it right. By the way. And so in another problem, let's say like this one up here, if you found that the cotangent was undefined, the cotangent of 0, you can just do the tangent of 0 and then do 1 divided by that answer. And if your calculator freaks out, then you know you did it right. Okay? So the calculator can really kind of just affirm anything you wanted. And sometimes I find if you're just having trouble kind of remembering how to do these or some of these, there are some common decimals that'll pop up when you're checking your answer in the calculator, like this 0.707. That 0.707 is almost always a square root of 2 over 2. The square root of 3 over 2. Oh, I don't want a negative in front there. The square root of 3 over 2 is a very common decimal you'll see, 0.866. So if you just do it in your calculator and you see 0.866 with these decimals after, when you're evaluating, you can assume it's square root of 3 over 2 as well. The square root of 3 is common. The square root of 3 over 3 is common. So if you kind of start seeing these decimals often enough, you'll know what the fraction form is supposed to be, which might save you some time while doing these problems. Just a heads up. This is kind of the shortcut guide to doing some of these evaluations. All right.
All right.
Well, that's it for the checkpoint stuff. If you want to get some more practice before the quiz tomorrow, in your textbook, I would say you can try out some of the problems that have evaluating the sine, cosine, tangent, and well, any of those problems really. Anything from 13 to 30 on page 275 is fine. This is just in case you need extra help, extra practice with it. And the odd answers are in the back of the book. So if you want to, I would recommend doing the odd problems just so that you can check your work and get the answers for it. 31 through 35 are problems like example 2. 43 through 47 are problems like example 3. And you know how I am normally with these quizzes. I'll probably throw in a true-false question, maybe even an error analysis one. So if you want to practice an error analysis one, there's one in your textbook on number 57, page 276 is in there as well. Okay?
Okay.
Yes.
Got you.
All right. Putting it out there. Any further questions, you can send it to me through chat or email or One of them Johns.
One of them Johns.
That was tough. That was tough.
One of
We
them
miss you,
Johns.
Eric, and Kylie and Aaliyah. And I feel like I'm missing somebody else. 1, 2, 3, 4, 5, 6, 7. No, that's all right. 1, 2, 3, 6, 7. Who else am I missing? And Maddie. Maddie. We miss you too, Maddie. There we go. All right. I'm going to stop recording now.
Okay.
Okay.
Can you